Good morning, my name is Alex, and in this short video, we'll talk about how to implement a simple and robust lip sync Visemes in our sample embodied AI Unity application using Azure Speech SDK. So here we are in the GitHub on the left hand side. We did some additional modifications to enable lip sync Visemes. We also uploaded some design files. So this is the initial Blender file with its associated FBX. We also have a Maya file with the associated FBX. To implement lip sync Visemes, we used Maya, which is described on the right hand side, and a shape editor to introduce blend shapes for different variations of the mouth, mapping phonemes to Visemes. And this is how it's implemented. So basically you have an initial position, initial mesh that represents the character's mouth. You place this in the scene. Then you introduce multiple variations, so-called targets, in blend shape editor. Then you change positions of the vertices for the mesh for different targets, for representing different Visemes. And just please note that as you create targets, as you create copies of that mouth shape, just simple scaling will not work, so you have to adjust positioning of those vertices. And then also we introduced the last one here, the mouth neutral. We introduced the neutral position, which is the same as the original position, which will come handy when we map Viseme number 0 from Azure Speech SDK in the code. This will come handy. We'll come back to that. So basically, first of all, to implement Visemes, you have to understand some of the timing of what we'll be dealing with. And this is just a quick representation of what to expect. So we have the Azure Speech SDK, and the speech synthesizer class allows you to capture and catch a Viseme received event, which gives you Viseme ID and audio offsets for different Visemes for a specific utterance. And you can see that top line represents Viseme ID, so we may receive something like 0, 1, 16, 1, 13, and so on. And the bottom line represents audio offsets for a typical utterance. So it may be like 0, we received at 50 milliseconds, 1 comes in after 95 milliseconds, 16, 228 milliseconds, and so on. So the difference, the delta between like the receipt and how we should play those Visemes, between 0 and 1, it's 45 milliseconds, then 193 milliseconds. This gives you an idea about like how precise you would like to be. And then if you have to catch those events, like if you're playing your audio clip and if you're playing Visemes, you can catch those events at appropriate times. And this is just for comparison, like you will catch them as precise. You would like to catch them as precise as possible, but it may not be as precise, and it's only a matter of milliseconds, right? So like this is 0.152 milliseconds difference, and then like in some cases, for example, it may be a couple of milliseconds, but this can be neglected. So for example, in here it's 447 milliseconds, and then as I caught that event, it was 454 milliseconds. When you have your project, I have my project set up for 60 frames per second, and then just for kind of comparison, one frame takes 16.66 milliseconds. If you have 30 frames per second for your project, then one frame will take 33.33 milliseconds. And you can compare those numbers per frame to the deltas here. So that just gives us an idea, intuition about what's the best way to implement Visemes. And then as you implement Visemes, basically, I'll zoom in here, in the main class, which is the sample manager class. So we basically introduced a set of variables to support the process. So we have Visemes dictionary, which maps phonemes to Visemes. We have Visemes list, which collects all of the Visemes for a specific utterance. We have skin mesh renderer, which comes when you import your FBX, and blend shapes will be associated with the skin mesh renderer. We have a game object, which we tagged for convenience. And then we have transition duration. So this speaks to like 100 milliseconds transition out from the previous Viseme when we deactivating it. So that just like speaks back to those timings. that we just described. So this will be reasonable to have like 0.5 or 0.1, which is 50 milliseconds or 100 milliseconds for transition out. And then we have a current Viseme ID for a specific playback of Visemes. This is just for internal variable that we take advantage of. Then we have phonemes to Visemes mapping. So we have basically implemented for A, E, I. This all comes down to, like, if we receive one from Azure Speech SDK, we map it to blend shape number 10. This is how that works. Then after that, we have implemented this specifically by means of a coroutine, because this is what our intuition tells us the best way to do. So before we play, we actually start animating lip sync Visemes as a coroutine. And then with just a few lines of code, essentially just 20 lines of code, 20, 30 lines of code, we can implement robust lip syncing. So this is the loop for all of the Visemes that we collect. We calculate timings, and then we in the game of kind of deactivating and activating Visemes. So if we have to deactivate previous Viseme, this is how we do it here through another coroutine. Then we activate the current Viseme, and we basically take into account the Viseme duration. So note that there's a Viseme count -1, and then there's a I+1 here that gives the Viseme end. So all of those offsets, the current and next, we use for Viseme duration calculation. What's interesting is that the Viseme, in the Viseme list, the last Viseme received will correspond to 0, to silent. So that's why, like, when we deactivate in the last one that we activated previously, we're not losing anything. We're coming back to the status quo on the neutral shape of the mouth. And then we clear the Visemes list to prepare for the next utterance. And then activation, deactivation, basically it's the start of the coroutine, very simple. So we're going from 0 to 100, which 100 is the maximum range for the blend shape weight. And for deactivation, we're going from current to 0. And then the heart of this is lerping between blend shapes and lerping blend shape weight. And this is used in both activation and deactivation coroutine. And this is how it's done with just a few lines of code, keeping this extremely simple yet very robust. So let's see how this works. So if I navigate to Unity, and this is my hierarchy here. So we have mouth as a separate game object here. We tag this with the tag for convenience of linking to that specific game object. And then we have all of those different blend shapes right here. So from 0 to 11, from mouth L to mouth neutral. So let's see how this works. So I actually implemented a simpler graph that just speaks out like a couple of utterances. And we also, in the debug log, we also capture all of the Visemes captured. So in the format of 0 being Viseme ID and 50 being audio offset. And then all of those Visemes, you will see how they will play with the mouth. So let's launch the experience. We'll wait for 5 seconds to kind of warm things up with Unity Visual Scripting.
Azure OpenAI is a cloud-based platform for training and deploying artificial intelligence models provided by Microsoft and OpenAI. Thank you for your attention.
All right, and just like that, we implemented Visemes. Note how all of those blend shapes played before your eyes. Thank you for your attention.